Welcome to Walkabout the Galaxy, the multimedia astronomy podcast where the science is universal, the opinions are personal, and the studio is educational. We are Strange, Charm, and Top the Astroquarks, also known as Josh Cole, Addie Dove, and Jim Cooney, coming to you from the Walkabout studios at the University of Central Florida. Walkabout t-shirts are now available in exchange.
Oh my gosh, I'm so excited.
Where do I get it?
For donations to the UCF Foundation. Choose your shirt at walkaboutthegalaxy.com. Today we're joined in the studio by special guest Dr. Adam Burgasser, who leads the Cool Star Lab at the University of California, San Diego, which is just a very cool name.
That sounds
for
awesome.
your lab, the Cool Star Lab. Adam, welcome to Walkabout the Galaxy.
Thank you very much. It's great to be here.
Good to have you here. We'll be talking a little bit about your research, and you can tell us about brown dwarfs coming up. First, our stumpers are zoological.
Okay.
It's a word.
That is.
For no particular reason, Jim.
Yeah.
Koalas or kangaroos?
Oh.
I was not expecting that.
I was not expecting that. It has nothing to do with astronomy.
I told you it was zoological.
I'm going to go with kangaroos because I feel bad for them. I think that I've never been to Australia, but here's how I feel like it is. I feel like everybody loves koalas, and then everybody thinks that kangaroos are like a pest.
I think.
But I think they're friggin' awesome.
Baby kangaroos are adorable.
They
too.
are
Little
adorable.
joeys.
Yes.
Yeah. Adult kangaroos are adorable. I guess they kick
so good at
the
kicking
hell out
and
of you,
hopping.
but yeah.
Yeah.
Anyway, so I'm going with the underdog kangaroo.
Kangaroos. Okay. Addie, pandas or sloths?
Sloths.
Oh, no hesitation.
That was quick. You're
It
usually
was pretty easy. Yeah. There was just a great John Oliver bit about how useless pandas are and how pandas won't even like
To get down to business
get
and
down
take
to
care of
business
business.
with each other because they're so disinterested in everything.
So that's why they're
That's why
almost
they're
extinct.
almost extinct. Is 'cause they're like, I don't even care enough to reproduce for this species.
Yeah.
Oh.
So, but sloths, pretty awesome.
And
And
I guess
my
they do
spirit animal,
care.
because if I could just hang out like that and just move slowly all the time. Actually, I don't move slowly ever, so it's fine.
Sloths definitely move slowly. I wonder if reproductively they're like Sting. Like, do they do that very slowly too? They take forever?
Yes.
We don't know.
I don't know.
Okay.
I haven't researched that.
And we have a stumper for you. It's not
All right.
zoological.
Oh,
That's up your line of research. T-dwarfs or Y-dwarfs?
T-dwarfs.
Oh.
Well, that was
Okay.
quick also.
Yeah.
Why?
Yeah.
Seriously.
Because that's what I studied as a graduate student. They're like mine. You know?
Okay.
Yeah.
All right.
Your babies.
You stay
I
tuned.
did
White dwarfs
decide,
are good,
I
but
did
they're
decide
also-
earlier today. Oh, sorry, go ahead.
No, well, I was just going to say white dwarfs are great, but it sounds too much like white dwarfs, which is going to force all of us to have better diction.
That's true.
So,
Okay.
Or
Well,
like,
work.
why
Which we
dwarfs?
That's
Yeah.
true.
yeah, white dwarfs.
White dwarfs.
T-dwarfs. All right, well, we'll have you tell us what T-dwarfs and Y-dwarfs and L-dwarfs and all those different kinds
Yes.
of object are in a minute. We'll also talk about Big G. Saturn is now the Lord of the Moons, as well as the Lord of the Rings.
Taking all the crowns.
Yeah. But first, this episode of Walkabout the Galaxy is brought to you by the fabric of spacetime. Cheap, reliable, stain-resistant, and malleable, the fabric of spacetime is your conduit for your Walkabout the Galaxy. Infinitely stretchy, the fabric of spacetime provides broad, sweeping expanses of flatness, looping hyperbolas for slingshot rides around stars and galaxies, puckered black holes and fluttering gravitational waves traveling in all directions at the speed of light. While the fabric of spacetime swirls indefinitely around pulsars and even your home planet, it never gets twisted into a knot and is guaranteed not to clog your sewing machine. So remember to use spacetime for curtains, Halloween costumes, dresses, jackets, or any of your fabric needs. The fabric of spacetime, your flexible friend.
Very nice.
That's
Sounds
pretty great.
good. I want it.
It sounds very forgiving as a fabric.
Your flexible friend.
Oh,
Thoughts?
that's a tagline from something else.
Oh,
We're supposed
A
to
real thing, which,
real thing.
spoiler alert, you will not guess,
Oh.
because I've never heard of it.
Oh, I was going to
Therefore-
say like Band-Aids or something.
And therefore, that's actually a good guess.
Thanks. It happens sometimes.
It's
Yeah.
not actually, I mean, I think it's a good guess.
But it's not correct.
It's not even close to what the correct answer is, though.
Give us
It's
like
not a
the
good-
genre.
as a guess, it was a
Not
good.
a good
it was
guess
good.
in
As an
that
answer, it was
way.
terrible.
Yeah, exactly. What's the genre of thing?
The genre is transactional. That's a very weak
Bank of
clue.
America or something.
It's
Yes,
along
yeah.
that lines, yeah.
Visa debit card.
It's a credit-
Diners Club International card.
Yeah, the Access credit card.
Oh.
Mm.
Is that like the Magnum credit card?
I don't know. I have never used the
The Magnum credit card was the credit card created by the folks who created Fire Festival.
Oh, my goodness.
Oh, fire
That
with
sounds
a-
like it was probably flexible. As in,
Yeah. It was a
Dissolvable.
bit of a scam also, yeah.
Yeah. Access credit card, 1978, and probably no longer existed in 1979.
They had credit cards back in 1978.
Oh, pooey. Space news.
Space news. Icon launched last night.
From
I was
here?
really excited about that. It launched from the airplane took off from Kennedy Space Center, and then a rocket gets dropped and then launched.
I wasn't
So
even
it's a
aware
Pegasus
of
XL.
Okay, it's a Pegasus. And I didn't think they ever did those from here.
They usually don't. And it originally was supposed to go out of one of the islands somewhere, like 3 years ago,
Like
2 years
Aruba?
ago. No, I don't remember.
Like
And then it got changed, and then maybe it was going to go out of
what
Hawaii.
An icon is what?
The
International?
Ionosphere
Oh.
Connection Explorer or something
that
like
sounds
that.
right.
So it's looking at the ionosphere. So it's looking at the interactions between weather that comes up and space weather and how that affects the ionosphere.
Oh, okay. Where the
Charged
Earth
part of the
and
atmosphere.
space meet.
Yes.
Yeah.
Neat.
Some sad space news.
Oh,
Alexei
yeah.
Leonov, the first spacewalker, died. His spacewalk was in advanced trivia question.
1960.
So far, so good. So far, still good.
2.
2. 1.
3.
5.
Whoa.
Yeah. He died at 85, and his only other flight in space aside from that one was the Apollo-Soyuz
Oh, nice.
mission, where he was one of the two Russians astronauts on board. His spacewalk, his first spacewalk, 12 minutes and 9 seconds, and I apparently had a somewhat frightening turn of events because his suit started like overinflating or something, or it like ballooned out, and he wasn't sure he'd be able to get back in, so he actually reduced the pressure,
Oh, wow.
which runs into possibly getting the bends or something
Yeah,
like that.
yeah.
So, but he ended up working out okay.
Yeah, those
for
early
him.
spacewalks were super crazy. Like the Gemini ones, too. They just opened the hatch
Open the door,
in the
yeah.
spacecraft.
It's like,
and it's like,
crack
all
the
right,
door
I'm
open,
going to
float
go outside
outside.
now. Ed
Yeah.
White lost a glove.
Yeah.
I'm sure they lost
It's
some other
probably
stuff.
it's burned up by now.
Yeah.
In spacewalk news,
Oh, yeah.
NASA finally got another medium spacesuit shirt up to the ISS, so that the famous all-female spacewalk
Can
that
continue.
was going to happen in the spring will happen later this month. It's
Yep.
currently slated for October.
They're doing a ton of
Yeah.
spacewalks this month. They just
did one today.
One today, and they did one like 3 days ago.
Right.
They're replacing some batteries, upgrading the batteries on the space station.
Right.
Ooh, which is relevant to the Nobel Prize.
Yes.
Oh.
It is?
Chemistry.
Yeah, the Nobel Prize in
Oh,
chemistry was
chemistry.
for lithium-ion batteries.
I was like, really? What?
Nice.
Yeah.
gonna
How
say,
does
because
exoplanets
yeah.
relate to the batteries
are
on
they
the space
using
station?
I don't
Lithium-ion
actually know if they're
batteries? Okay.
lithium-ion batteries, but they are batteries.
That's actually
Yeah,
an
batteries,
interesting
yeah.
question, because lithium-ion, definitely NASA's very
Conservative.
pays very much
Yes.
attention to lithium-ion
Things that
batteries.
blow up, yes.
Yes. Yeah. So that'll be happening later, and that'll tie into our trivia when we get to that later. But Adam, let's come back to your T-dwarf,
Sure.
Y-dwarf stumper. Tell us
Yeah.
about what is a brown dwarf. Anyway?
Actually, before we start on that,
Oh.
I have a quick question for Adam, because this is something that has plagued us.
Plagued.
On the show a few times when we've talked about dwarfs before. It's the fact that you pluralize the star
Oh,
dwarf
this is the
with an
dwarfs
S.
versus
Dwarfs
dwarves.
versus
Dwarf, yeah. And
Controversy.
we knew that was the case, but we don't know why. And you study these things. Maybe you know something about why. Why do we do that?
Why do we do dwarfs?
Yeah, why do we do dwarfs instead of dwarves, which is how you pronounce the little guys?
So I did at one point, because I was also bothered by this.
Yeah.
And I did at one point look it up, and they are equally acceptable.
Okay.
So it's just
So-
a sort of
So it's
cultural
it's just
tradition.
adopted.
So
Interesting.
Snow White and the Seven Dwarfs is with an F also.
Really?
Yeah, I looked that up the other day because I was like, that's not right, but it is.
I thought that wasn't. That's crazy.
The Disney movie
So it's
is,
just
yeah.
so both are acceptable, and it's just
And that's just what's
certain
passed
ones
by,
are
yeah.
used or not used.
Exactly.
Yeah.
Okay,
Yeah.
I apologize.
Which is also, maybe I'll talk about it, is why we use T and Y. We just started using them. There were other letters that were available, but because we just kept using them, that's how they
Yeah.
got to
They
be.
stuck.
There's
Oh.
no reason except we used them.
Well, I was in a. I'm gonna before we get to the dwarfs, since we're on to the language
yeah.
thing now.
Uh-oh.
I was in.
We're never going to stop.
I know, but I was in a play once where the word BANAL was spoken by another character in the play. So let me quiz you all. How would you pronounce that word BANAL?
I'm gonna embarrass
Banal.
myself.
Banal.
Banal.
So my co-star said banal, and my head exploded.
Because you had never heard that before?
Because I just like, that is so bad, that's so wrong, it's not pronounced that way. So we waged a low-stakes bet. And I went into the dictionary, and the first pronunciation was banal, but banal was listed as an acceptable pronunciation.
There you go.
And
Everybody's right.
I was a little worried there.
Yeah. My head is still explodes. My head is still exploding. But in the pronunciation line of things, in a recent episode, we talked about an old tree.
Oh, we did.
Yes.
Yeah, that was found in New Zealand.
Yes.
We didn't find it.
No. And this tree had some very intriguing clues about the speed and
duration
of magnetic field reversals.
Yeah.
And we've talked before also about, like, right now our Earth's magnetic field may be tests in the waters of doing some interesting stuff. And so this tree was
the kauri, or I'm not sure if I'm rolling that R correctly, but we'll add in a little clip, and we got a great pronunciation from a listener. So thank you for that, Richard. And we'll add that clip into the podcast.
Yes. And so that, I think, brings us up to speed on language for this episode.
Okay.
So,
how about them
so
dwarfs?
far,
how about those Y dwarfs and T dwarves?
Why dwarfs?
Why? Yes. So So brown dwarfs are a complete separate class of object. They are things that are somewhere between stars and giant planets.
And is there a way to say it's a giant planet or a brown dwarf definitively, or is that a kind of unanswerable dilemma?
Well, in practical speaking, if you are applying for NASA funding, it's a planet.
Always.
Oh.
Almost always.
There's never a time
we
when
really stretch it to
NASA never
to
really
get,
wants to give money to study brown dwarfs.
Yeah, no, they're not into it as much as planets. But it's a good question. We don't know. We don't know if you think of brown dwarfs as an extension of stars down to low masses,
Right.
then we don't know if that stops before you get to the highest mass planets or if they overlap in some way.
Okay.
Yeah.
So the smallest brown dwarf could be smaller than the biggest planet.
Entirely possible, yeah.
And then the difference between them just sort of be how they formed, like whether it formed like Jupiter or it formed like the sun.
And that's also hard because we can't watch them form, so we just have to get based on clues.
Right.
And there's also now new ideas about these particular objects may be forming in different ways, different from planets and stars. So there may even be other formation mechanisms. So it's kind of the Wild West on these objects.
Okay.
Yeah.
And so there, in stars, we have OB, A, F, G, K, M,
Right.
N, or RNS.
RNS, yeah.
Stars, which are meaningless letters based on what
They're
the spectrum
historically
meaningful.
Rearranged
Yes,
letters.
yeah.
Yes, there was yeah.
Was at some
Once
point.
upon a time, there was some reason.
They did go from A to O,
They didn't
yes.
just pull like letters out of a Scrabble bag,
Yeah.
Right.
but they might as well have, based on what we now know about those stars.
Yeah, I mean, they were sorted just by appearance of spectrum. And then when we finally figured out the physics of what's actually going on, we realized that the sequence was out of temperature order,
And we lost some.
and we lost some.
Oh yeah,
It was just easier to reorder the letters than to reclassify
and give them new
100,000
letters
spectra,
because they require erasing too many things.
Yeah, and erasers were very hard to come by in the 19th century.
There we go.
So now we have how many different kinds of brown dwarf types?
So we classify brown dwarfs in 4 types. There's late M dwarfs. So M dwarfs are the most common type of star, but the youngest brown dwarfs are also late M dwarfs.
And are they really young?
Oh yeah.
Okay.
Yeah. We find things that are just collapsing down, which will have enough mass or not enough mass, and will form something like a brown dwarf.
Okay.
So we see all those stages of formation.
But when you say, and then when you say late, what does that mean?
Okay, thank you for pointing that out, because that's a good language thing. So when we say early or late type stars, we mean hotter or colder.
Yeah.
But it's left over from when we didn't actually know how stars worked on the inside, and we assumed that stars started off really hot, and then they cooled off and became really cold. So they were early and hot, and they were late and cold. And obviously that doesn't.
It's not
how
not
it
so
works.
much. Right.
Except it's how it works for brown dwarfs, because the thing that separates brown dwarfs from stars is that they don't have enough mass to fuse hydrogen in their cores.
So they don't have their own internal energy source. So they really do just sort of cool
and they
off.
just cool off. So we've managed to get ourselves back to 19th century physics again.
Yay.
Great. So sort of like planets like that then, right? in some ways.
In some way, absolutely. So
Yeah.
I mean, they're all about the same size as Jupiter when they get old enough, and they have the same compositions. They're cold enough to have clouds and molecules and stuff. So
I guess this is showing my ignorance, but I had thought that some of them did fuse to make deuterium in their interiors. Is this true or no?
You're absolutely right. So I said when I say didn't fuse, they don't fuse hydrogen because that's the kind of longest lived fuel. Massive brown dwarfs will fuse deuterium and lithium, but if you get down to about 1% the mass of the sun, then it's never hot enough to fuse anything.
Okay.
Yeah.
Okay. And so late M types are your biggest
Those
brown
are
dwarfs.
our hottest, earliest, youngest, brown dwarfs, and then they get colder, and then they turn into L dwarfs.
Oh, so that's a key difference between that's kind of typing for brown dwarfs and stellar types, because an O star will never become a B star.
Yeah.
More or less, yeah.
Well,
more or less, yeah. There's
mostly.
little weird stages that happen afterwards. But
you should never say never.
You
on the
should
main
never say never.
sequence,
Say never
on the main
in science.
On the main
sequence,
yeah.
those letters map to a mass.
Yeah.
On the brown dwarf sequence, they map to a temperature, which does not not necessarily exactly the mass.
Right.
Yeah.
And I
So-
learned today that L-type stars have a lot of potassium.
Type brown
L-type
dwarfs.
dwarfs.
L-type brown
L-type-
dwarfs.
Yep, those.
L-type, yes, L-type.
They're basically the bananas of brown dwarfs.
Bananas. Oh, yes.
Potassium.
So many
Get your
yeah.
potassium.
Yeah.
Yes, they have these massive lines of potassium. They're just super broad because there's
Right.
nothing else to get in the way of their absorption. And
Right.
they're
Spectral
pretty cool.
features. So
Spectral
looking at the
features,
spectra
yes.
of those things.
Yep.
And then so it goes M, L, and then T, and then Y.
T, and then Y, yeah.
And we've never really seen, have we ever seen really for sure a Y type?
Oh, we have dozens of them now.
Oh.
Yes.
Dozens.
Yes. The Ys, so there's another Y sound, the Ys survey
Oh, yeah.
found the Y dwarfs.
Oh, man. Is that why it's called that?
It's
No,
the
no, no.
Y.
Is it because everybody was like, why do these exist?
So I should talk about letters. So,
Oh.
yeah. So
We
so
do
it's-
like talking
We'll
It's
talk
the
about- we'll talk about
Sesame-
language,
It's
yes.
the Sesame Street Astronomy
Yes.
Podcast.
Yay.
So, when I was a grad student and we were finding these L and T dwarfs for the first time, there was a period where people were trying to figure out what to call them because they were new letters. And my advisor, whose name is Davey Kirkpatrick, who's at Caltech IPAC, and kind of defined the L dwarf class. In his paper, actually wrote down all the letters of the alphabet and explained why each one of those is not suitable for a spectral type.
Oh, and L was the only one available.
Well, L was available, T was available, H was available,
Oh,
Y was available,
okay.
and Z technically is available, but that's kind of aggressive to say that you found the Z dwarf because
Yeah.
you're like saying I found
The
last.
ultimate one.
Yes,
Yeah.
Okay.
So,
So
yeah.
H and Z are still out there for some
H
amazing
is
discovery.
available and Z is still available. Yes.
Okay,
Yeah.
all right. So you heard it here first. If
Yeah.
you make an
Act
amazing
now.
astronomical, right? Act now.
Yeah.
There's only 2 letters left.
I think if you get the web address now, it's a good time.
Right.
True.
Zdwarf.com.
There you go.
Well, transitioning from brown dwarfs, which are transitional, sort of in some way, perhaps between planets and stars.
Oh, I thought you were going to go with the letter transition.
Oh no, but we've got so many transitions
So
we
many
can play with
okay,
today. There's planets and moons, and there's some interesting space news about one of our nearby planets, Saturn.
It has moons.
Has 20 more moons than we were previously aware of. So
Yeah.
the count now for Saturn's moons, do you know the number? Did you see
No,
the total?
it's high.
82.
That's correct.
Yay!
All right. Nice.
82.
Was that the trivia?
No. Edging out Jupiter,
With
which has
81. I'm just kidding.
79.
At this point,
That
At
we know
this
of.
point that we
Yes.
know of.
Yeah.
And there's a caveat I have to disclose for one of Saturn's
There's
82.
an asterisk on it.
Well, I would put a pretty big asterisk on it. It's this thing that we saw in the B ring that Cassini observed one single picture of a shadow, a bright spot and
yeah.
a shadow. And we don't really, it's like it's in this dense ring. So it's not on its own orbit. So like,
It
all
wouldn't be a
the-
planet.
I mean, no, exactly. All the
Yeah.
controversy about whether Pluto's a planet is because, oh, well, it's not by itself in its orbit. This thing is nowhere close to being by itself in its orbit. And there are a bunch of things other things like that in Saturn's rings that we've seen, and why aren't they
Yeah,
being
this whole
counted as moons?
counting of moons is squirrely anyway, right? Because every ring particle could be
Is
called
a
a
moon.
moon in some
Yeah.
sense.
We got
So-
trillions.
You
Or
always
tri-
talk
yeah.
about moonlets, right?
That's right.
In the rings, typically, where they're
there's
little
transitional
baby.
between moons and ring particles. Anyway,
there's a
this one
spectrum.
this one of the 82 in particular, I would say,
Probably
gets
just a big ring
gets
particle.
a big asterisk on it. Well, it may just be a big clump of ring
ring particles,
Yeah.
right?
Yeah, it's definitely
So-
a lot. I mean,
It's bigger.
hundreds of meters out of the ring plane, and the rings are only 10 meters thick at that location. So it's
And we should
it's a big unusual thing.
Yeah, and all these new moons are just little things with a few kilometers across or something like that, right? So I mean, these aren't exciting new giant moons like Ganymede or Titan or something.
Well, they're
like
at
that.
least not gigantic.
right.
They
might
may
be
exciting
exciting.
in some
Yeah.
ways. So,
I suppose.
To some of us, they might be exciting,
I
Jim.
guess so.
these moons, these 20 moons, are probably fragments from a smaller number of larger moons that were broken up, and they're potentially in this late cataclysm, 4 billion years or so.
Ooh, 17 of them are retrograde.
Ooh.
So, and most of these were sort of imaged with Subaru, right? The telescope Subaru.
I'll take your word for it. That's in Hawaii.
In Hawaii, yeah.
So a lot of small objects in the solar system. As you said, most of those 82 moons, not just these 20,
Right.
but most of the other 62 are tiny. There's
Right.
only
Yeah.
a half a dozen or so good-sized objects orbiting Saturn, and even around Jupiter, those 79, they're mostly tiny pipsqueak captured guys.
Little moons.
Yeah.
Maybe X-asteroids.
Right. Yeah. Or fragments of something that was a bigger X asteroid or something like that.
If I start a band, I think it would be the X-asteroids.
Oh, really?
No.
It was
There's so many good band names you can come
Z-Dwarf.
up with.
The X-asteroid?
Z-Dwarf
Yeah.
would be also
Z
really good.
Dwarf.
There you go.
Yes. Type Z Dwarf.
There is a band already that's called Star Death and the White Dwarfs.
That's true.
Yeah.
Is that your garage band?
It's a band run by, I don't know, like the nephew of the guy in the Flaming Lips.
Oh.
Speaking
Anyway.
of nephews, your academic relative
Oh,
had some
yeah.
big news.
Yeah, we had some big
Oh,
news.
yeah.
Of course, this is the time of year. I don't know when you're listening to this podcast, but we're recording the podcast during the time of year when the Nobel Prizes are announced.
Nobel season.
Oddly, once again, the astroquarks were bypassed.
We once again got by, but not by that far this time, right? So
true.
That was a near miss.
yeah.
It was a close approach.
My PhD advisor is a guy named Jim Fry at the University of Florida. His PhD advisor was a guy at Princeton named Jim Peebles, who
it's a long
shared.
line of Jims.
Yeah, it's all
sequence.
Jims. Yeah, I'm gonna when I get
All
a
the way
graduate
down.
student, it's gonna be Jim. So he won the Nobel Prize, or half of the Nobel Prize. The Nobel Prize often these days is divided up and given to a few different groups.
But never more than 3 people if it's given to individuals.
Right. So this year it was given to 3 different people divided into 2 groups. Right. So half of it was given to Jim Peebles. Jim Peebles works on what we call physical cosmology, or the large-scale structure of the universe. And it wasn't given for any specific thing. It was given kind of for his
General awesomeness.
he was for the sum total of his contributions to this field, which have been voluminous.
Yes.
He's the grandfather of the large-scale structure of the universe, and lots of things like our ideas about what, the temperature of dark matter. Well, that's a weird thing to say, but dark matter, cold dark matter is our idea.
It's not as weird as voluminous. though.
was that not the right word?
Voluminous.
Voluminous. That's the word I was looking for. Voluminous. That's not even a word. I'm
It
an
was
idiot.
close.
It is,
Can
it
you
is
spell
now. It's
that
on
in Scrabble?
It's on air.
Maybe
it's in
you're-
that.
It's-
Yeah.
all right, fair enough.
Is there non-physical cosmology?
Well, yeah.
Yeah.
That's,
What's the other
Unfortunately, there
kind?
is a lot.
yeah.
Is it
theory.
New Age cosmology? Nice burn.
Zing.
Ouch.
String theory.
So yeah, that was really cool for us in the field of large scale structure. That Jim Peebles, he's been a luminary in the field forever, and he finally got a Nobel Prize, which is great.
Your academic grandfather.
Academic grandfather. So next year
Does
should
that
be Jim
mean-
Fry, and the year after that,
Exactly.
bam,
That
Jim
is the
Cooney.
way-
There you go.
that's
That's
how it
usually how it
That's
goes.
definitely
how it
how it
works.
works.
And we should mention, of course, that the other half went to a pair of researchers who were
The better half.
The first to discover.
first
an
to discover
exoplanet.
not necessarily
around a sun-like
Yeah.
star.
right. So there were some exoplanets
There's
found
little
around what
qualifications.
neutron stars a while back, but
Oh.
but this was the first. And using this radial velocity Doppler shift technique that it was used to find all of the first planets.
Dozens.
So that's really great. I mean, opening the window on this universe of exoplanets. So that was really
the very first one was discovered with Arecibo because it was around a pulsar.
Oh, nice.
Mm-hmm. Yeah.
Yeah.
So you study
and they were
exoplanets,
rocky.
and they were
I think we think they're rocky.
Really?
They're small. Yeah.
because they're small.
But this was an exciting. I mean, this was an unexpected discovery because in the scientists are Michel Mayor and D.A. Kalo,
and it was Kalo's PhD work, right?
His PhD work. So
That's amazing. Yeah,
the pressure is up for everybody.
I know, right?
Yeah.
Grad students better get on that Nobel Prize winning work now.
Right.
But it was a very unusual discovery because it was a massive planet, but it was right up against the star.
Yeah.
And no one had expected that.
Right.
And
all of our models and all of our modelers had been working on trying to understand how do we explain our solar system, and we were doing a pretty bad job of that. And then they were like, hey, by the way, most other planetary systems aren't like ours.
Right. Surprise.
Surprise.
Yeah.
That's how science works.
Right. Let me give you your trivia before we talk about cosmology.
Trivia time.
So, Adam, just so you know, I know you're going to know the answer. Don't blurt it out.
All right.
Don't blurt it out.
No,
We'll come back. We'll come back to the answer. We want to make Jim and Addie suffer here on this one.
So he's way smarter than us, so he's going to know the answer and we're done. I mean, he is. That's probably true.
Your words, not mine.
Fair enough.
So we had some astronaut news. We've got the spacewalker.
I love
So it's an
astronaut news.
It's an astronaut related.
Oh no!
See, I'm not going to know
It's
this.
an
I'm
astronaut
not going to know
related.
this either.
Everybody knows who the Mercury 7 were. Maybe not. Can't recite off the top of your head all 7 names, but the Mercury 7 was NASA's first group of astronauts. Each group of astronauts, as it happens, had a nickname like the Mercury 7. The Mercury 7, that original set was selected in 1959, is known as Group 1. Through 2017, there have been 22 groups of astronauts selected, and each one's gotten a nickname, except for one group. Which of the following is not a nickname of one of the NASA astronaut groups?
Z-Dwarf.
Okay, you ready? Your choices are
The Volumnus 7.
Not
Not it.
that'd be a good band name too. Your choices are the scientists,
Okay.
the extras, the maggots, the flying escargot, and the sardines. Believe it or not, 4 of those are
real. Yeah, I
actual
believe that.
names of groups of astronauts hired by NASA, analogous to the Mercury 7. Only one of them is not. Bonus, if you can guess which group number out of 22 the 2 women astronauts who will be spacewalking together later this month are from, and mind-blowing props if you can guess what the name of that group is as well. Because if your choices are things like maggots and the flying escargot and the extras, then it could be anything.
It could be anything.
Could be anything.
Yeah. Okay. So ponder that.
Okay.
Yeah.
I'm not going to be any help here.
Jim, I got a
We're gonna throw
question
us
for
off.
you.
Yes, sir.
It's about Big G.
Big G. My
Speaking
favorite
of letters,
G.
Yes.
This is
It's
our Sesame
that's the
Street
Sesame
letter
Street
podcast.
episode.
It's a spectral
Today's-
class for stars, but also
It's the spectral class of our star.
of our
Exactly,
star, the
yeah.
sun.
it's also one of our favorite equations on the podcast. G equals 8 pi over RT.
That's right. We'll have to explain that to Adam later.
Okay.
But that turns out to be the equation that explains all of general
Universe,
relativity
yeah.
and stuff. So, not really.
Sure.
But it's related to what I wanted to ask about. So G is the specific G I'm asking about is the G that shows up in Newton's equation for gravity, sometimes called Newton's constant or Newton's G or something like that. I always just call it Big G. What do you call it?
Gravitational constant. Universal
Gravitational constant.
Yeah.
And the universal is a
Is
big
the
part of
important
it.
thing, yes.
Right, yeah. And so this is
Not the Disney gravitational constant.
It is not the local to Orlando.
right.
Gravitational constant.
So it says something about how strong the gravitational force is between 2 objects, and there's been research to try to see whether or not it's always had the same value, or is it changing? Is it the same everywhere?
One of the cool ways we measure G, actually, is by the lunar laser retroreflectors. So we bounce lasers off the moon, and that actually helps us get a better handle on G.
Oh, right. Because
So we left mirrors on the moon, and we can get specific distances and timing and stuff like that, and it helps us constrain big G.
So how do we reconcile big G with general relativity? Because, isn't big G just wrong?
No, not at all.
Yeah.
So G, big G is...
Don't go messing with big G.
Big G. So obviously big G is Newton's gravitational constant, Newton's universal gravitational constant. But of course, in the limit that the gravity is not so strong, general relativity should look exactly like Newton's physics, right? So physics on the scales of solar systems or the Earth are very well described by Newton's physics. And so even though general relativity is a vastly different description of what gravity is, it looks just like Newton's gravity if gravity is weak, like it is around here. And it turns out G has always been a notoriously difficult constant to measure, right? It's very precisely because it's very small. And we say very small, that's because gravity is very weak. So if you're trying to look at the gravitational force between two steel balls that you know the mass of.
The concave, maybe.
Two things in your lab.
It's really hard to measure the gravitational force between them because that gravitational force is so very, very small. And so we use things like in the solar system, like Eddie was just mentioning, to measure G. And whether you're talking about general relativity or Newton's version of gravity, you're going to get the same results in the solar system. So there's no problem. That G appears in Einstein's equations in general relativity, just like it does in Newton's versions.
Okay, but is it? I'm running the risk of asking some questions that reveal just how ignorant and stupid I am. But
we do that every episode.
Isn't that what this is all about?
Oh no, I've done this before. But you were saying in weaker gravitational fields, general relativity looks like Newton's gravitational thing, but to how many decimal points, basically? In other words, it's always off by a little bit,
yes.
isn't it?
Yes.
Even here on the Earth, our GPS satellites famously have to take general relativity into account.
Yes.
Even though we're not dealing with black hole masses or anything like that.
That's true.
So it isn't just exactly like Newton's formula.
No, it's not. It's
not
exactly.
And the reason I'm asking all this is because there's a story about taking a look at a really old star,
right?
And that's 11 billion years old, at least, and studying it. So this is a star, not a brown dwarf, but a regular main sequence star, but probably an M star, but maybe a K star. But
it might be K, yeah.
something like that.
It's probably pretty far away.
That's a main sequence star that's been burning, just chugging along for a very long period of time. And based on their studies of that star, have determined that G is constant to within 2 parts in a trillion, equivalent to knowing the distance between Los Angeles and New York City to the width of a single bacterium, if you want. Even that's not a great analogy.
Give me an
because
analogy, they don't really know how big a bacterium is.
It's this big.
It's very small.
They're very small. And so that means that G hasn't changed over the past 11 billion years. So I guess that's saying something about the temporal constancy of it.
Right.
But if I compare G to general relativity, do I know it to be correct out?
We don't know. No, we don't know G
points?
to nearly that many decimal places, but it's okay. I mean, G appears in both GR and in Newtonian physics. And
so I don't need to worry about Newton.
You don't need to worry about that. But you should worry. I mean, the point of this the point of this article is that we call it a universal constant. I mean, there are really 4 big fundamental constants, and we talk about them. And big G is one of them. What are the other ones?
Speed of light.
Planck scale.
Is that alpha?
Planck's constant.
Is that because I was going to take that one?
It's H.
Which
H.
one is H?
H bar is Planck's
Is
constant.
alpha the other one?
No.
What's the 4th one?
Fine, alpha. You
What
want
is
alpha?
it?
What is it?
I don't know. What is it?
We're asking you. We gave up, and we're asking you.
I don't even know.
Well, that's terrible.
That was terrible.
We're all
There's
terrible.
4. What is it? G, H, C.
It's the pion mass.
Really?
Pion
Yes.
mass.
Really?
So much. It depends on the pion mass.
Are you being serious or are
I'm
you
being
trolling
serious.
us right now?
You can do so much physics with just the
I
pion
think that
mass.
there's a bunch of. I think that there aren't really just four, but alpha, which is related to the electron charge, is one of them. Anyway, it doesn't matter.
Alpha's one that
does
does
matter.
get tested astronomically as well.
Right.
But why are there just 4? What do you mean by just 4?
Maybe there
there
aren't
like
just
a ton
4.
of constants?
There's lots.
There are
but
constants,
they're ones that
but
we
most
can
of the
test.
things are built on
I don't
a
think
small
any
handful.
of you know what. I know. I don't know what I'm talking about.
Yeah,
I
we
think
don't know.
you, Adam, know what you're talking.
Yeah, he's a smart guy.
I just fake it better.
He's fake. Yeah. So I probably shouldn't have said that without knowing. But anyway, there are only a handful of fundamental constants. But here's the thing.
What's
Here's the thing about
happening?
this. Is we call them constants because we're assuming that no matter where you go and no matter when you go in the universe, that they're the same numbers. And we make that assumption without really explicitly knowing that that's true. So measuring the value of g, for example, or c, the speed of light, when the universe was very young is a challenging thing because it's not that age anymore. But it's interesting to try and do that. And a lot of people have over the years suggested that maybe they're not constant. Maybe they do have a time dependence. But every test we've done so far has shown that they do seem to be constant. And that's what this most recent result is it was a look at a way to test whether G was the same 10, 11 billion years ago as it is today. Turns out, to the best of our ability to measure, it is.
And this is sort of an interesting sort of measurement that they did, because what they used is data from the Kepler Space Telescope, which is a mission that we've talked about a lot because of its discoveries of so many exoplanets, by looking at the dimness or the change in the brightness of a star as an exoplanet passes in front of it.
That means it was just staring at stars for a long time.
Yeah, a lot of stars.
And so there's all this cool stellar seismology stuff that's
pretty
been done.
at very high precision.
Yeah.
About just how steady and bright are these stars, and one of those stars is KIC 7970740.
It's my favorite.
Remember that one.
Yes, to the rescue. 3/4 the mass of the sun, so that probably makes it a
K star.
A K star.
Maybe early G.
Only and it's been on the main sequence, been burning hydrogen for at least 11 billion years. And what they did is combined that those measurements with models of what you were just talking about, Addie.
The seismology.
These stellar seismology.
That stuff's pretty cool.
Yeah, so stars oscillate, and as they do, their brightness changes.
Yep.
And
just if you're staring at it for a long period, and actually that was one they sort of didn't expect to get that much data on that when they put up Kepler. They didn't expect so much variation,
Right.
and so we're learning a lot about different types of stars and this variation. But it also made it even more complicated to get out the signals of the exoplanets
Right.
because you have to model the stellar signal really well to understand if the brightness changes are due to the star or to a planet.
yeah.
So the better we can model those, the better we can even get even more planets potentially.
I mean, it's a recurring theme we've been talking about in a lot of the modern astrophysical observations. Is there's this very interesting but large background signal that makes it so, like with gravitational waves, like the truck driving by down the road is a
phone
bigger thing
ringing,
than the actual, the phone ringing.
Yeah.
How about in brown dwarf stuff? What sort of observational challenges do you have to work with?
I mean, the biggest one is that they are just very faint. So you need extremely large telescopes, and most of the time we are fighting to get just enough photons to make any kind of measurements.
Will-
And in the UV, right?
In the
Or not,
infrared.
sorry, in the infrared.
In the infrared, yeah.
And will James Webb revolutionize brown dwarf
Well,
astronomy?
I mean, James Webb will revolutionize anything in astronomy. James Webb will revolutionize is going to be true. But yeah, it's going to be because James Webb is actually an infrared telescope for
Right.
the most part. So it's going to be right in the wave band where we can get lots of great data for these objects.
I like to call it
It's gonna be
J-dub,
so hard to get time on that,
It'll
though.
be
Yeah.
so hard to get time on it. yes.
Right.
especially if it doesn't launch.
So, well,
We
were-
don't say that.
No, sorry.
When it launches,
When
and
it launches,
successfully gets into its
yes.
L2 orbit.
James Webb is sort of an astrophysics in the astrophysics part of NASA, and
So
you
you
were
can talk
saying,
about stars then, not just
yeah.
planets.
So we were saying that you were saying that brown dwarfs. If you want money from NASA to study brown dwarfs, you call them planets. Does that when you're asking for time on JW, will you be calling brown dwarfs stellar objects,
Ooh.
substellar objects, and selling it to the astrophysics division?
Well, so to be serious, I mean, the reason we do that is that we do have this kind of range where it's not really clear. And, there are aspects of brown dwarfs that are so planet-like that we, even though they are isolated and floating around by themselves, we could, for better purpose just be studying a planet, and we don't even know if it was a planet. So,
Right.
yeah,
Could be a rogue planet.
We talked about rogue planets on a recent episode, and one of the things that was really interesting to me from your talk earlier today was the rogue brown dwarf.
Yeah.
That 70,000 years ago. Tell us a little bit about that.
Yes, so this is WISE 0720 minus 0846 AB.
Good memory.
Obviously.
I was going to say, I thought it was that one.
Exactly, yeah. So this was an object we found that was about 6 parsecs away, so still pretty close.
6 parsecs, about 18 light years, right?
And the interesting thing about it is it's moving directly away from us at about 80 kilometers per second.
It's a
Hightailing it away.
GTFOing.
Hightailing its way out. It has done something.
GTFO.
It's GTFOing.
GTFO 80. I got it.
I don't know.
It's getting the fork out of here.
GTFO.
It's getting the fork out of here.
Yeah. So anyways, when we backed...
We adopt good place terminology. It's the good place, astronomy podcast.
Yes.
So we tracked back where it would have gone, and because it's just going straight away from us, it must have come back from us. So when we figure out the close distance, it's something like 50,000 AU, about 70,000 years ago.
Oh, that's like inside the Oort cloud.
Inside the Oort cloud. So as I mentioned earlier today, that it's possible that it triggered some comets, and we only got about 2 million years to prepare for that.
Right.
Yeah. So have people done some dynamical calculations of like if it perturbs some comets, how long they'll take to sort of come in?
Surprisingly not. I haven't seen those calculations yet. I know folks are thinking
right
about it a little bit, but it's still just one little star passing through. So,
Right.
Even the Oort cloud is pretty sparse out there.
Yeah.
Right. So the Oort cloud being this big sort of spherical volume of comets that are very, very weakly gravitationally bound to the sun, and there is evidence in the past that there have been sort of episodic increases in the flux of things coming into the inner solar system.
Yeah.
And it from potentially from disturbances from objects such as WISE 3777.
And the other thing is, we only found this object about 5 years ago, and when it passed by, we humans without telescopes wouldn't even have seen it. So
even though it was so close, it's so dim,
so red.
Right.
So who knows? There may be other stars that are passing by us on a pretty regular basis.
Right.
Yeah.
Perhaps even now. Yeah. All right. What are your thoughts on
It'd be so cool to be able to see in the infrared.
J-Dub.
That's my thought.
J-Dub to the rescue.
J-Dub.
Yeah.
Yes.
Turns out,
I meant with my
infrared
eyes,
doesn't get through the atmosphere very well, so it wouldn't
true.
do you very much good on the surface of the Earth, at least in Florida.
especially in Florida.
Yeah.
You'd be wearing sunglasses all the time, and then your sunglasses would be hot, and you would still be blind. And your eyelids are hot. So it'd be
What if we
man.
could just get? Maybe in the future we'll be able to put like filters in our contacts. You could have like a UV filter or an IR filter in your contacts.
Sure.
Anyway,
It's coming. Okay.
Yeah.
Trivia. What were the choices again?
The choices were
the maggots.
the maggots, the scientists, the extras, the flying escargot, and the sardines.
I believe it is the science. I'm not going to go first.
Go first. You started. Finish.
I think it's the scientists.
Jim.
I have the sardines. Although
Adam.
that sounds reasonable, but that's
Flying
maybe
maggots.
why he said
The flying maggots. It's not the flying. It's the flying escargot
Sorry.
or the maggots.
Oh, okay. Well, then I was right. It's not the flying maggot.
That's true.
I'm going to go with flying escargot.
The flying escargot.
Yeah.
It's actually the extras.
Oh,
we're all
that might
wrong.
be.
I fooled you
What were the
all.
odds of that?
Yeah.
So
I wish I knew the story behind the naming of these groups. The scientists is maybe sort of self-explanatory.
Yeah. Is
was
that more
group
recent?
4.
Oh.
That was group
Okay.
4. So probably the first
Interesting.
time that they had scientists
scientists,
in
yeah.
there. So I'm guessing, I didn't check, but I'm guessing Harrison Schmitt, Jack Schmitt was in that group.
Huh.
Neil Armstrong was in group 2. I don't remember
Yeah.
the name for that one. The maggots was group 10. The flying escargot was group 15. The sardines is the largest group so far to date, group 16. There were 35 NASA and 9 international astronauts in that group. There have been 22 groups. Christina Cook and Jessica Meyer are the 2 astronauts on ISS who are spacewalking later this month. Which group do you think they were in?
19.
We're in 22 now.
22 was selected in the year 2017.
So 20.
What did you guess?
19.
18.
21.
Wow.
Okay.
21.
I knew it was one of the more
We all got it
recent ones.
right.
They're
Nice job, guys.
relatively new
We're awesome.
astronauts.
Relatively new astronauts, and the nickname for Group 21 is the 8 Balls.
Ink balls.
8 balls?
The 8 Balls.
Do they all do a lot of drugs?
I mean,
or play a lot of pool, I'm going to go with?
you've got the flying escargot in there, so and the maggots.
Maggots, I feel like there's a lot of like military folks
Yeah.
who
Yeah.
were early astronauts especially. So I feel like the maggots is just a military thing. But I don't know.
I don't know. Maybe so. Anyway, I stumped you.
You did.
Yeah.
Bad
too.
job, us.
While it may have felt like the time for a sloth to climb a tree, it was just another episode of Walkabout the Galaxy. If you liked this episode, write us a review in dark paving bricks in your backyard and leave them there until the Zillow satellite photo of your house is updated to show it. Be sure to like us on Facebook to get all our updates and check out our website at walkaboutthegalaxy.com. Click on WTG Stuff to see our collection of t-shirts and buy 2 or 20. Let us know if there's other WTG merch you'd like to see. Subscribe to our YouTube channel, Walkabout the Galaxy, where you can see Jim nodding off while I'm talking. Catch up on old episodes wherever you get your podcasts. Thanks again to Adam Burgasser for joining us today. Thanks to our listeners in Hawke's Bay, New Zealand, and around the world. Follow us on Twitter.
At @walk_the_galaxy.
And ask us questions anywhere using hashtag #WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Our production assistant and video guru is Diego Rodriguez. I'm Josh Caldwell.
I'm Addie Dove.
I'm Jim Cooney.
We're the astroquarks signing off until the next episode of Walkabout the Galaxy.
Z-Dwarf.